Okay, in this video series, we are going to discuss about the physics for class 11th. And our main focus will be on covering the syllabus of ISC board and NEET exam. We are going to cover the syllabus of ISC and NEET in this video series specifically for the class 11th students. Okay, now look at the syllabus. These are the 10 chapters that we are going to discuss in this video series. If you look, all the 10 chapters can be divided into the 5 units. The first unit that we are going to discuss is mechanics. The second unit we are going to discuss about the gravity. The third is a fluid mechanics. The fourth one is thermo. And the fifth one is waves. These are the 5 units that we are going to discuss in this video series. The syllabus of class 11th. In the mechanics, if you will see, in the first chapter we will discuss about unit of measurement. Just I am giving a brief idea about the syllabus. Then we are going to discuss about the errors in the chapter number 1. And the chapter number 2, kinematics, we are going to discuss about motion in straight line. Then we are going to discuss about uniform and non-uniform motion. And we are also going to discuss about the vectors. Then in chapter number 3, we will discuss about the Newton's law of motion. Newton's law. The first, second, third. Chapter number 4, we are going to discuss about the work, energy and power. A rotational motion, we are going to discuss about the rotational motion and circular motion. Here some more topics are there that we are going to discuss in the first unit mechanics, like center of mass, momentum of force, the equilibrium of the rigid bodies. These are the basic topics that we are going to discuss. In the chapter number, what we are going to discuss in unit number 2, gravity, we will discuss about the Kepler's law. And we are going to discuss about the gravitational potential. In the chapter number 7, unit number 3, we are going to discuss about the viscosity. We are going to discuss about Stokes' law, Bernoulli's theorem, here we will discuss about the thermal equilibrium in unit number 4. And the last unit, the wave, we are going to discuss about the wave motion and the longitudinal and transverse waves. Discuss a Doppler effect. And these are the basic topics that we are going to discuss in the syllabus of class 11. Similarly, if you look for the class 12, here also 10 chapters are given. Total 5 units are there that we will discuss in the second video series when we are going to cover the syllabus for the class 12 physics. This is a basic idea about the syllabus. Now start the chapter number 1. Here, if you look in the books, you will find that when the unit number 1 is mechanics and the first chapter is physics and measurement. Okay, if you will look at your books, you will find the topics like error measurement and the unit in the chapter number 1. But here we are going to start with a vector algebra. Basically, you will find this topic in chapter number 2 in your books. But here we are starting with a vector algebra because the vector algebra is a basic mathematical tool that we must know for the better understanding of the topics that we are going to discuss in the first unit mechanics. That's why we are starting here with a vector algebra. Now, put a heading like physical quantities. Physical quantities. Okay, what do you understand by the physical quantities? The quantities which can be measured are known as physical quantities. It means the physical quantities are the quantities. Physical quantities can be measured. We can say the physical quantities can be measured, like force, torque, time, mass. These are the physical quantities that we are using in our physics and can be measured. That's why we have written the physical quantities can be measured. Or we can define the physical quantities as by means of which we describe the laws of physics. We describe the laws of physics. Now, if you look, all the physical quantities around you can be categorized into the three types. If you look, the few physical quantities we are having, that is having a magnitude only, and few physical quantities are having a magnitude and unit, and few are having a magnitude, unit and direction. Now look for the first case, the physical quantities which are having a magnitude only. For example, if we take a refractive index. Refractive index, what is the unit of refractive index? There is no unit of refractive index. Why? Because it is a ratio. No? It is a ratio. It doesn't have any unit. It is only having a magnitude. For example, I have just, it is suppose it is written what? It is a magnitude. There is no direction, there is no unit. Now look at the second type of physical quantities. The quantities which are having the magnitude and unit. For example, I am taking a charge. Suppose in an example it is written like the 5 coulomb of charge. 5 coulombs of charge. What is a 5? 5 is a magnitude. And what is a coulomb? It is a unit of measurement for the charge. It is a unit. They are quantities which are having a magnitude and unit, and this type of quantity are known as scalar quantities. Scalar quantities, the quantities which are having a magnitude and unit only. Another example, if you look, mass. Now it is having a magnitude and unit. Now look at the third type of physical quantities which are having a magnitude, unit and direction. For example, take a force or velocity. Lots of examples are there. Velocity. By asking someone to apply a force on one block, what you will ask? You will ask them apply 10 Newton of force, and you will also tell him apply in this direction. It means you also need a direction to define the force. This is the magnitude of force. This is a unit of force, and this defines the direction of force. To define a force, we require three things: magnitude, unit and direction. That's why this type of quantities are known as vector quantities. Okay, is it clear? The first type of quantities which are having a magnitude only. The second type of quantities which are having a magnitude and unit, and this type of quantities are known as scalar quantities. And the third type of quantities which are having a magnitude, unit and direction, and we call them as a vector quantities. In the third, we have introduced the direction. Okay, if someone is asking, or in exam it is asked, what is the definition of scalar and vector? How to write? Scalar, the physical quantities which has magnitude but no specific direction. For example, mass, distance, speed, etc. Similarly, what are the vector quantities? A physical quantities which has magnitude as well as direction and follows the vector law of addition. For example, force, velocity, torque and etc. The new term is introduced in a definition that follows the vector law of addition. We are going to discuss this, don't worry. Let's take an example of force. And we are going to check whether the force is a vector quantity or not. Suppose there is a block and you have applied a force of 10 Newton from this side and you have applied the same amount of force, 10 Newton, from this side. Now answer me, if you have applied a 10 Newton force from this side and 10 Newton of force from this side, whether the box is going to move. Whether this box is going to move. No, box will not move. Box will not move. Now, consider the same box and the same forces. Suppose this was name given to this force was F1 and name given to this force was F2. Suppose the F1 is in same 10 Newton, and now you have changed the direction of F2. Now you have applied the F2 from this direction, that is 10 Newton. Just answer me whether in this case the box is going to move. Yeah, box is going to move in this direction. Box will move. Box will move. The same forces F1 and F2 applied in this type of direction, then the box is not moving. When you have changed the direction of F2, now the box is moving. It means the change in direction has impacted the result. The result is changed as you have changed the direction of force. It means force is a vector quantity. The vector changes on changing its direction. This is a key point to remember. Force is a vector quantity. It is necessary to define the direction of force, and it is a direction dependent quantity. That's why we call the force as a vector quantity. Now take another example of current. For example, just take this, look at the first diagram. Suppose the 3 ampere of current is flowing in this path and the 3 ampere is coming from this side. What will be the resultant? Resultant, you will get a 6 ampere of current in this direction. Now I am going to change the direction. Suppose the same 3 ampere is here, 3 ampere is here. What resultant you are going to get? Again it will be, it means here we have changed the direction of the current, but the result is same. The result is same. It means that flow of the final current doesn't depend upon the direction of the input one. It means the current is a scalar quantity. It doesn't follow the vector law of addition. It does not follows vector law of addition. That's why we call the current as a scalar quantity. These are the basic examples for the vector and scalar quantities. Okay, now we will look how to represent. Okay, before that, these are the 3 points that must be fulfilled for a physical quantity to be a vector. It has a magnitude, it has a direction, and it follows the rule of vector addition. These are the 3 points that the quantity must fulfill to become a vector quantity. Now we will look how to represent a vector. For the geometrically representing the vector quantities are represented by the symbol of arrow. Suppose there is a box and we want to represent how much force is applied, then we will represent the force with arrow. All the vector quantities are going to be represented by the sign of arrow. Okay, suppose 2 vectors are there. This is a vector number 1 F1 and this is a vector number 2 F2. If we look, the first vector is already represented by the arrow. This is the head of a vector and this is known as a tail of a vector. And remember, if the magnitude is more, length of arrow is going to be more. Length of arrow is going to be more. It means, suppose I want to represent a 10 Newton of force, then I am representing it with this much of length, and the same diagram I want to represent a 5 Newton of force, then the length must be half. This is a basic representation of the vector quantities. Basic geometrical representation of the vector quantity. The same thing I have written. The length of an arrow will be proportional to the magnitude of the vector quantity. This is just a basic idea how to represent a vector. Now we will look how to represent it in a Till now what we have discussed the how to geometrically represent a vector. Now we are going to discuss how to write a vector. Suppose there is some vector quantity and I want to notate it. How I will notate the representation for that vector quantity? I will write English alphabet and I will draw the arrow like this. Now this is a vector representation of any vector quantity. This is a vector quantity. This is a vector quantity. This is the exact representation of a vector quantity. Suppose it is written like modulus of A. What it represents? It represents the magnitude. It is discussing about the magnitude of vector quantity. This is also represented by just simple alphabet. It means in exam it is written like magnitude. It is same as A. Both represent the magnitude of vector. Magnitude of vector quantity. Magnitude of vector quantity. This is the vector quantity, English alphabet and arrow symbol over it. Suppose I have written vector F is a 10 Newton and direction is north 10. Suppose it is asked what will be the value of this. It means it is asking the magnitude. You will write 10 Newton. 10 Newton. Or it is what is the value of F? You will write same 10 Newton. This is a complete representation of a vector. This is a magnitude of that vector. This is a magnitude of that vector. This is a basic representation of the vector. The same thing I have written over here. If you want, you can go through it. Now we will discuss how to find the angle between the two given vectors. Suppose the two vectors are given like this is the vector number vector A, and the another vector is given as B. This is the vector B, and it is asked what is the angle between vector A and vector B. How to represent it? First draw one vector and another and draw them tail to tail, and this angle between them is known as angle between two vectors, vector A and vector B. This is a angle between vector A and vector B. Now take another example. Suppose we are having a vector A like this and this is a vector B, and it is asked what is the angle between vector A and vector B. What we will do? Draw the two vectors tail to tail. This is vector A and this is vector B. This is the angle between, this is a positive angle between two vectors. Positive angle between vector A and vector B. These are the basic method to find the angle between two vectors. How to geometrically find the vector between the two vectors? Then you need to add them tail to tail or draw them tail to tail. Then you will find the angle between them. The same thing I have written. To find the angle between two vectors, we have to place them tail to tail. Now, this is an important topic that we are going to discuss. The component of vector in the direction of theta. Suppose there is one vector A this is a given vector A which is making angle theta from the x-axis. This is my x-axis. It is making angle of theta from the x-axis. Now it is asked what is the component, what is the projection of vector A along the x-axis. How to draw? Draw the perpendicular from the head of the vector to the x-axis. We know, suppose there is one vector is represented by A. What is the meaning of A? It is the magnitude of A now. And magnitude is represented by the length of the vector. It means this is the magnitude now A. This is a A. when we are combining the magnitude with direction, it gives the complete vector. So can I call this length is the A now? This is the magnitude of vector, length of the A, vector A. So can I write this as a cos theta, this length? Change the color. This is a cos theta. This is a cos theta. Similarly, suppose this is a y-axis and you want a component or projection of vector A along the y-axis. Draw a perpendicular. This length will be A sin theta. A sin theta. This is a projection of vector A along the y-axis. And the yellow color, this is a projection of vector A along the x-axis. Now, in exam, suppose it is asked, represent this in terms of vector. No? How to find the vector? Magnitude A cos theta multiplied by the direction. What is the direction? X-axis. We represent a unit vector along the x-axis as the I cap. Don't worry, we are going to discuss these things later. I cap. This is a complete vector. But when you are finding the component or projection, basically we used to find the magnitude. That's why I have written over here vector, not vector A cos theta I have written over here. But if you want to find a vector in this direction, you need to multiply a magnitude with a unit vector of that direction. But we don't worry, we will discuss this again. Take another example and find the components of this vector. Suppose here it is given like this is a vector A and it is making angle minus of theta or theta from x-axis like this. This is x-axis, this is y-axis. And it is asked you find the component of vector A along the x-axis. Then what you will do? Draw the perpendicular. Suppose this is vector A and the magnitude is going to be A. Now the length of the vector is going to be the A magnitude. Then this projection will be A cos theta because it is making angle theta from the x-axis. And the same, if you want a projection in y-axis, draw a perpendicular from the head of the vector. This length will be A sin theta. This is a projection of vector A along the y-axis. This is all about the component of a vector in a direction of theta. Now we will discuss how to add two vectors. How to add two vectors. Suppose there is a vector A and vector B. Now we are going to add these two vectors, find A plus B. And always remember the vector addition is commutative process. What do you mean by commutative? Vector A plus vector B will be same as vector B plus vector A. This is known as a commutative process. That's why I am calling the vector addition is a commutative process. Now look, there are two methods of vector addition. There are two methods of vector addition. The first is a triangle method. And the second is the parallelogram method. We are going to discuss these two methods of vector addition. First we will discuss the triangle method. Now look, the triangle method. Suppose there are two vectors like vector A and vector B, and it is asked to add the vector A and B and find the resultant. How to add them? Vector B, suppose this is vector B, then I need to draw the another vector like this. The head of the first vector is going to be the starting point. We are going to put the tail of the second vector at the head of the first, and the resultant will be given by the tail of the first and head of the second. This is going to be the yellow color. This is going to be the resultant vector. This is vector B, this is vector A, this is going to be the vector C if vector A plus vector B resulting in C. This is a method to find the resultant vector using the triangle method. Now take another example. Suppose the vector is B is given like this, and this is vector A. This is vector B and this is vector A. Sorry, this is A. And how to find the resultant of these two vectors? If we are going to add vector A and vector B, what will be the resultant? Now, as per the triangle method, draw one vector and I'm going to draw the vector number A from the head of the first vector. Suppose this I have taken this as a B and this is a vector number A. The resultant will be given by the tail of the first and head of the second. To whom I am free to choose anyone as the first and second, and this will give me the vector C, the resultant vector. This is a resultant vector. This is a resultant of addition of A and B. Here, this is a resultant of addition of A and B using the triangle method. This is a geometrical representation of addition. Now we are going to do the analytical analysis. We are going to find the values. Suppose there are two vectors, like this is vector number, not vector number, this is vector B and this is vector A. And it is asked what is the value of A plus B. What is the value of A plus B? First, add them as per the triangle law. This is vector B. This is vector A, and this is vector B. How to draw the resultant? Resultant will be like this, now tail of the first, head of the second. This will be the vector C. I am assuming A and B resulting in vector C. Now, the one thing I am going to do, extend this line, drop a perpendicular from here to this extended line. Suppose the angle between the two vectors is theta. Okay. Now look at a triangle. What is going to be the value, length of this line? This is going to be magnitude A multiplied by cos theta, because for the vector A, the magnitude is going to be the A. A means length of that line, and theta angle is given over here. It means the length is going to be A cos theta. Now this is a complete base of the triangle. I am just naming. Suppose this is a P, this is Q, and this is O. Now this point is O. Now look at the triangle PQO and apply the Pythagoras theorem. Where here we are going to apply the Pythagoras theorem to the triangle PQO. The resultant vector is C. The magnitude of the resultant vector, or it is represented as C now, will be equal to the, what will be the magnitude of this? A, sine theta. Now A square sine square theta plus base. What is the base? This is vector B now. Magnitude will be B. B plus A cos theta. This is a base. That's why I have written A square sine square theta, B plus A cos square theta. Now I'm going to solve this. C is equal to under root of A square sine square theta plus B square, A plus B square. I'm using a formula, A plus B square, plus 2AB cos theta. This is a, just I have opened the formula and open this bracket using the formula A plus B square. Now look, from this term and this term, I am taking A square as a common in a bracket, it will be sin square theta plus cos square theta which is equal to 1. That's why I'm writing directly as a square. Now b square plus 2ab cos theta. This is a resultant we are going to get. This is the magnitude of vector c. This is a magnitude of vector c when we have added vector a and vector b. Now imagine this angle is phi. Phi is the angle between the vector b and the resultant. Now use trigonometry, find the value of tan phi. Tan phi will be given by a sin theta divided by base. Base is b plus a cos theta. It means how to find the angle of resultant from the base b. This is the formula for that. This is a magnitude of the resultant. This is the angle of the resultant from the base vector. And these are the two formulas that we have got by solving this triangle method. You need to remember these two formulas. Okay. Now we are going to look for the another method, which is a parallelogram method. Parallelogram method. A small difference is there, but the resultant is going to be the same now. 1 plus 2, whether which method you are using, you will always get a result as a 3. Same here. In the parallelogram method, we are also going to get a same result. Only the method is changed. Here, suppose this is vector A, this is vector B, and it is asked to find the addition of these two vectors. Vector A plus vector B. I'm assuming the resultant is C. Then how to add them? Vector A and vector B. This is vector B. In the triangle method, we have just started the second vector from the head of the first one. Here we are going to add them tail to tail and now complete the parallelogram. Now complete the parallelogram. And the diagonal of this parallelogram will give the resultant vector. The diagonal of the parallelogram will give us a resultant vector. This is the basic parallelogram method of vector addition. Now how to find the resultant? How to find the magnitude of resultant? Drop a perpendicular from here. If you will see that this blue line is same as vector A. Same as vector A. This means this length will be what? Suppose this angle is theta. This is also going to be theta. The blue line is same as vector A. It will be A cos theta. And this perpendicular will have a length of A sin theta. Now all the calculations are going to be same as triangle method. Here also you will find vector C is equal to, not vector C, magnitude of vector C will be equal to A square plus B square plus 2AB cos theta. And this angle is suppose phi, the angle of C from the B, you will get tan phi is equal to A sin theta divided by B plus A cos theta. This is the angle that you are going to get, and this is the magnitude of the resultant that you are going to get over here. Okay, now look at the final conclusion, what we have got from this triangle method and parallelogram method. I'm writing a conclusion. Suppose there are two vectors, vector A and vector B, and it is asked what is the resultant of these vectors. Suppose vector A plus vector B gives a vector C as a resultant, then what is the magnitude of the resultant? The magnitude of the resultant will be given by under root of magnitude of first vector square plus magnitude of second vector square plus 2 A, B cos theta, given theta is a angle between given vectors. Theta is angle between given vectors. And it is asked, suppose phi is the angle of resultant from the B, then tan phi will be given by A sin theta divided by B plus A cos theta. This is a angle of resultant from B. Now suppose it is asked the alpha. Alpha is an angle. So it is given like alpha is an angle from A. Angle of resultant from vector A. Then how to find? Then tan alpha will be given by same. Replace A with B and B with A. Magnitude of B sin theta divided by A plus B cos theta. This is a formula to calculate the angle of resultant from the vector A, and this is the formula to calculate the resultant of vector B from the resultant. These three formulas you need to remember. Now on the base of these three formulas we are going to solve two numericals. Okay, now look at the given numericals. Very simple. It is given the angle between two vectors. Two vectors are given as vector A and vector B. The theta, angle between two vectors, is 60 degree, and the magnitude of vector A, we call this as a inner, is 5, and the magnitude of vector B is given as 10. And what it is asked? It is asked what is a magnitude of A plus B. We call this as a C. Now it is asking a magnitude of the resultant. Very basic question. The C, we know the formula. The magnitude of the resultant is given by A square with B square plus 2AB cos theta. Now put the values, you will easily get the answer. C is equal to under root of, what is the value of A? 5, means A square is 25. What is B? 10. B square will be 100 plus 2 multiplied by 5 multiplied by 10 multiplied by cos 60. Now look, 25 plus 100, 125 plus 100 multiplied by cos 60 is 1 upon 2. This is going to be 125 plus 50. C is equal to under root of 175. This is a magnitude of resultant. This is a magnitude of resultant. And it is also asked what is the angle of resultant from vector A. Suppose we have assumed the angle of resultant from vector A is phi, then tan phi will be given by B sin theta divided by A plus B cos theta. Remember, we are calculating from the A now. That's why I have written a formula B over here, B over here. What is the value of B? B is 10 multiplied by sin 60 degrees. Sin 60 is root 3 by 2. What is the value of A? 5 plus B is 10 multiplied by cos 60 is 1 upon 2. The 2. This is going to be root 3 by 2. Tan phi is equal to, this is the angle of the resultant from the A. Or you can write tan phi is equal to tan inverse root 3 divided by 2. This is a basic example based on the addition of two factors. Now look at the another example. The same, based on the same formula. The magnitude of vector A is given, magnitude of vector B is given, and the magnitude of the resultant is given, and it is asked to find the angle between vector A and vector B. What formula we are going to use? We know the magnitude of resultant on addition of two vector, the magnitude of resultant on addition of two vector is given by under root of a square b square plus 2ab cos theta. Put the values and theta is asked. What is the magnitude of resultant of two vector? 5. I am taking the square root on this side. 5 square is equal to 4 square plus 3 square plus 2 into 4 into 3 cos theta. Simply solve for this. 25 plus 25 is equal to 25 plus 24 cos theta. Here you will get cos theta as a 0. It means what is the value of theta? Theta is going to be 90 degree. It means the angle between the given two vector is 90 degree. Very basic question based on the addition of two vectors. Similarly, now we are going to discuss what do you mean by the negative vector. What do you mean by the negative? Suppose vector A is given vector, and it is asked what do you mean by minus of vector A? Minus of vector A. Read the line. The vector having the same magnitude but opposite direction. Suppose this is a vector A. And how to represent a minus A? The same magnitude, only the direction is going to be changed. This is a minus vector. It means when we are multiplying a vector with a minus sign, only the direction of vector is going to be changed. There's no change in magnitude. Always remember, magnitude will not change. Only the direction is going to be changed. It means, suppose the vector A is given over here and the magnitude of vector A is 5. Then the magnitude of minus A vector is also going to be the 5. Magnitude is not going to be changed. Only we need to reverse the direction of the given vector. Okay. Now, on the basis of this concept, we are going to discuss the subtraction of two vectors. How to subtract the two vectors. Till now, we have discussed how to add the two vectors. Now, we are going to discuss the subtraction of two vectors. Just read the line. What is it over here? Subtraction is same as addition of negative. Just look what it means. Vector A minus vector B. I need to find this. Two vectors are given, vector A and vector B, and it is asked what is the meaning of vector A minus B. Just I am going to write it again as vector A plus minus of vector B. As mathematics, it is same, no? When the minus plus is going to multiply, we will get the same result. It means still I am adding two vectors. Still I am adding two vectors. The only thing is that I have reversed the direction of the second vector. Just look. Suppose here this is the vector A and this is the vector B. Then what do you mean by vector A plus B? How to draw? This is vector A. I am using a triangle method. Vector B. And we know this will give the resultant vector. But same, in the same case, suppose it is asked to find vector A minus vector B. What we will do first? We will find the negative of vector B. This is going to be the vector A. And what will be the negative of vector B? Vector B with reverse direction. Because we know this is B, then this is going to be the minus B. If this is vector B and this is going to be the minus B. That's why I have drawn like this. Now this will give the resultant. This is suppose vector C. This is vector A and this is minus of vector. Still we are adding two vectors now. The resultant will be vector A minus of vector B. Vector addition is just the vector subtraction is just an addition of vector, only we have changed the direction of the second vector. If you will find the resultant for this case, you will find like this. The magnitude of the resultant will be given by a square plus b square minus of 2ab cos theta. Rest of the things are going to same. This will be the resultant of the given vector because here minus is introduced. This is the resultant of the a minus b. A minus b, magnitude of a minus b will be given by this. Magnitude of a minus b will be given by this. Okay, one more law we are going to discuss, the polygon law of addition. Actually, in the books, rarely you will find this method. Just for the NEET exam, I am discussing. This method is used when more than two vectors are given. Suppose this is vector A, this is vector B, this is vector C. N numbers of vectors can be added using this formula. Okay, vector A, B, C. Then how to find the resultant of two vectors? It is same as a triangle method, only you need to add them consecutive. Vector A, then vector B. What we need to do? Continue with the same method. Vector C. How the resultant we are going to draw? The resultant will be same. The tail of the first one and head of the last. This is going to be the resultant of vector A plus vector B plus vector C. This is known as a polygon law of addition. We call it as a repeated application of triangle law. Okay, the concept is clear. This is a repeated application of triangle law. Okay, these are the topics that we have discussed in first lecture. Now in second lecture we are going to start with unit vector.